So for question number 4, letter A, basically the first thing we gotta do is find the derivative of the expression given. That is going to be 6x squared minus x, and then we're just gonna do this equals to 0 to find the values of x. Doing that, we find that x is gonna be either 0 or 1. Then we sketch just a straight line, and then we plug 0 and 1, the values given, and then we pick values in between those two numbers. So I pick -1, 1/2, and 2. And by plugging these numbers on the expression, we found that -1 squared times 6 is going to be 6, and -6 times -1 is going to be +6, so it's going to be bigger than 0. This means that it's going to increase. If we plug 1/2, we're going to have 6 times 1/2 squared minus 3, and doing that we are going to see that 6/4 is going to be less than 3. That's why if f prime is going to be less than 0 and f is decreasing. For 2, we are going to have 2 squared is 4, and 6 times 4 is going to be 24, minus 12, because 6 times 2 is 12, so this is going to be bigger than 0 and f is increasing. So by doing those calculations, we can assume that f is increasing on the interval of -infinity to 0 from here to here, and also from 1 to infinity, and it is decreasing at 0 and 1 in this interval. For letter B, basically we gotta do is pick the two x's we find to see where is the local maximum and the local minimum. By plugging 0 in the expression, we just got -36, and by plugging 1 on the expression, we got -37. So this is going to be our local maximum, and this one our local minimum. For letter C, he's asking for the inflection points in the interval where it's concave up and concave down. Basically, to find the inflection point, we just gotta do the second derivative. So then we're gonna just end with 1x, and then we're gonna solve this for x. So x is gonna be 1/2. So the point of inflection is 1/2, and the function of 1/2. By plugging this in the function, we got -56.5. After that, we gotta see where is the concave down and where is the concave up. Just draw a line, plug the point 1/2 that we got from here, and then we just pick 2 points, 0 and 1. And by plugging 0 on the second derivative, we're gonna get that the derivative of f of 0 is gonna be less than 0, so it's gonna be concave down, and the derivative of f of 1 is bigger than 0, so that's why it's concave up. So concave down from -infinity to 0, and concave up from 1 to infinity. And for letter D, I just sketch a graph based on the results that I got on the other letters, and that's my sketch of the graph.